Good afternoon, all. This is Satish Kumar, Assistant Professor of EC Department. Now, let us see the another video lecture series on discrete Fourier transform in discrete signals and systems. Empathy, discrete time signals and systems. These are the challenges in digital signal processing, difficulty in advanced DSP topics, weak basis effect that transforms and filter designs, need to reconnect the concepts, importance for applications, that is foundation for digital signal processing, discrete Fourier transform and is transform in terms of discrete time. Next one, define signals. A signal is a function of one or more independent variables which contain some information is called as your signals. See, electrical signals are radio signal and TV signal. Non-electrical signals are sound signal and pressure signal. For example, we can take it as traffic signal, red, yellow and green. See, each and every signal has different kinds of information. Red to wait, yellow get ready, green to go. Next one, noise signal. Noise is also a signal. Yes, noise which does not contain any information is called as noise signal. Next one, it is related with communication. Yeah, a communication system has an information signal plus noise signal. It is an interconnection of smaller system. It consists of transmitter, channel and receiver. Transmit to process, they convert the information into the signal and process with the help of channel. It is of wired or wireless channel that can be received the message signal through the receiver side. Right? Next one, these are the classification of signals. Discrete time signal can be classified into periodic and aperiodic, even and odd, energy and power, deterministic and random. See, periodic means if it repeats at regular intervals is called as periodic. Even signal and odd signal is said to be symmetric and anti-symmetric signal. Energy and power signal has finite energy and power. Deterministic can be represented by mathematical representation. Next one, define discrete time signal. First, what is meant by digital signal that are discrete in time and quantized in amplitude? It can be represented by zeros and ones. Discrete time signal that is defined for discrete instant of time. Discrete time signals are continuous in amplitude and discrete in time. It is denoted by x of n. Next one, periodic and aperiodic signal. It's said to be periodic signal if it repeats at regular intervals is called as periodic signal. A signal which does not repeat at regular intervals is called as aperiodic signal. Next one, even and odd signal. Even signal means the signal is said to be a even signal if the inversion of time axis does not change the amplitude. Example, we can take it as cosine wave. It can satisfy the condition x of minus n is equal to x of n. Odd signal means if the inversion of time axis also inverts the amplitude of the signal. Example, sine wave. Sine wave satisfies the condition x of minus n is equal to minus x of n. Next one, energy and power signal. See, energy signal has finite energy and zero average power. Unit of energy is joules. Power signal can be has finite average power and infinite energy. It can be represented in terms of discrete time. Energy is equal to n tends to infinite limit. Summation n is equal to minus n to plus n x of n the whole square. Power is equal to n tends to infinite limit 1 by 2n plus 1 summation n is equal to minus n to plus n x of n the whole square. Next one, deterministic and random signal. A signal which can be completely represented by any mathematical equation is called as deterministic signal. Example, we can take it as sinusoidal signal. Random signal means a signal which cannot be represented by any mathematical equation is called as random signal. Example, noise signal. Next one, these are the discrete time standard signals for using in terms of to analyze the DFT. U of n is equal to 1 for n greater than or equal to 0, 0 for n less than 0. The graphical representation can also shown. Unit impulse signal can be defined as del of n is equal to 1 for n is equal to 0, 0 for n should be not equal to 0. Unit ramp signal can be defined as R of n is equal to n for n greater than or equal to 0, 0 for n less than 0. Unit ramp signal is a linearly growing function. Next one, system. A system is a set of elements or functional blocks that are connected together to produce an output with response to input signal. Example, audio amplifier, receiver. Input signal can be applied to system which can produces the output signal. X of n can be applied to discrete system which can produces output as y of n. Next one, this is the example of audio amplifier of the system. Then first we can apply the microphone through mixer and then amplifies the signal. Finally, when to speaker, we can get that as audio amplifier. Next one, discrete time system. It operates on the discrete time signal which can produces another discrete time signal is known as discrete time system. X of n can be applied to discrete time system which can produces output as y of n. When x of n applied to dt system which can produce as y of n. In case of impulse response can be applied to discrete time system, we can get it as a h of n. Next one, these are the application areas. It is used in audio and speech processing, image and video processing, circuit design, biomedical engineering and military applications. And also it is used in acoustic communications in mobile phones, GPS, radar and sonar. Multimedia to compress the signals to store data such as CDs, DVDs, etc. And then biomedical, we can extract the information from biomedical signals. ECG signal, electrical signals are generated by the heart. EEG, electrical signals generated by the brain. Medical imaging, biometrics, fingerprint identification and iris recognition. Next one, we can see the assessment, a signal which contains information. List the classification of these signals. DT signals can be classified into periodic, aperiodic, even, odd, energy, power, deterministic and random. Define discrete time signal. The signal that is defined for discrete instant of time is known as discrete time system. It is denoted by x of n. What is mean by deterministic and random signal? A signal which can be completely represented by any mathematical equation is called as deterministic signal. Example, sine wave, cosine wave, etc. Random signal means it which cannot be completely represented by any mathematical equation is called as random signal. Example, noise signal. Define even and odd signal. Even signal means if the inversion of time axis does not change the amplitude. X of n is equal to x of minus n. Odd signal means if the inversion of time axis also inverse the amplitude of the signal. Example, sine wave, sine of minus theta is equal to minus sine theta. Give some applications of signals. It is used in communication systems, image and video processing, audio and video processing, image processing, and then military applications. It is used in biomedical signal processing, etc. Thank you.